So now we'll start the prerequisite of our course, that is EIMT. We have already seen our marking scheme. We have also seen what is the subject code and all these things. Now first, our prerequisite, we have already discussed. Our prerequisite was introduction of electrical power supply system, and the next was single line diagram, and from that the next prerequisite was classification of electrical distribution system. Now see, with the help of this single line diagram we can understand electrical power supply system. Now this is the generating station. At this generating station there is a generator or alternator which produces electrical energy, and the energy produced may be of either 3.3 kilovolt or 6.6 kilovolt, or we can say 11 kV. For our understanding we have taken 11 kV. So at generating station the generated voltage is either 3.3, 6.6 or 11 kV, and it is stepped up with the help of step up transformer to very high voltage level, that is say 132 kV. So it may be 132 kV, or it can have a greater value as 200 kilovolt or 400 kilovolt. So this voltage may be 200 or 220 kV or 400 kV. This is transmitted up to some distance, and this transmission is called as a primary transmission. Now see, this is a feeder. So what is a feeder? Feeder is a three-phase, three-wire system. So it doesn't have any neutral. So it's a high voltage. Feeders are used for high voltage system. So this stepped up voltage, it may be 220, it may be 132 kV, or it may be 110 kV. So it will be transmitted up to some distance, up to some receiving station, before which there will be a transformer. So this transmission will be called as a primary transmission. So always remember, always keep it in the mind that primary transmission is of the range either 110 kV or 220 kV, or we can say 132 kV or 400 kV. So after transmitting to such high distance, it's a long distance, it is stepped down to say either 32 kV, either 33 kV or 66 kV, and it is a step down transformer. So this step down transformer will reduce the voltage of 132 kV to 33 kV, or it may be 110 kV to 33 kV, or it may be 66 kV. So then this voltage is again transmitted up to some medium distances, and this type of transmission will be called as a secondary transmission. So secondary transmission is of the range 33 kV or 66 kV. After completion of this secondary transmission, further this voltage either 66 or 33 is stepped down with the help of step down transformer to the receiving station. So this was first receiving station at which we have obtained the voltage of 33 kV. It was coming under the secondary transmission, and then later on this is the second receiving station where this 33 kV was converted to 11 kV. Again up to this there is three-phase, three-wire system. So everywhere from this we can understand there is only a feeder system. So this will be called as a primary distribution. So this receiving station comes under the category what is called as a primary distribution, and after primary distribution there will be a transformer which will convert the 11 kV to 400 volt, 440 volt. So it is the system, or the transformer is delta star transformer. secondary winding of this transformer is star, hence we will get the neutral. So this outgoing of this transformer will be 440 volts. So again, for this 440 volt, we will get these various distributors where along with the neutral, the voltage between phase and neutral will be 230 volt, and between the two phases will be 440 or 415 as per the transformer specification. So this is all about the single line diagram and introduction to electrical power system, which was the prerequisite. See, a generating station generating the voltage at this level, this generated voltage is stepped up to either this or this voltage. This will be transmitted to some distance, that is a long distance. So this will be primary transmission. Primary transmission will have the range of 110, 132, 220 or 400 kV. After that, it will be stepped down and it will be again transmitted to some medium distances. So this will be 33 kV or 66 kV. So conversion will be either 110 to 33 or 130 to 33 or 220 to 33 or 400 to 33, or it can be in place of 33 we can write 66 also. So this will be the secondary transmission. After this, there will be step down of the voltage. Voltage will be stepped down to 11 kV. This 11 kV will be further transferred to the substation, whereby again this 11 kV will be converted to 440 volts. Now see, here the transformers are delta, but here at the distribution end we can find the transformer is delta star, where at the secondary side we will get the neutral. So this is all about the single line diagram and introduction to electrical power system. Distribution systems are classified according to type of supply, means whether the supply is AC or DC. And if it is a DC supply, then whether it is a 2-wire system or 3-wire system, or it is 2-wire system with midpoint earth. So accordingly DC will be classified. If it is a AC, then it will be either it is single phase or 2 phase or 3 phase. If it is a single phase, then again this classification will be same, like this AC will be 2-wire, or is it of 3-wire, or is it of 2-wire with midpoint earth. If it is a 2 phase, then there will be a further sub classification of 2 phase 3-wire or 2 phase 4-wire. Now if it is 3 phase, then it may be a 3 phase 3-wire or 3 phase 4-wire. Just now we have seen that after this will be 3 phase 4-wire, but from this end to this end it was 3 phase 3-wire, that is a feeder system, and 3 phase 4-wire is a distribution system. Now let us see, according to the construction, it is classified as overhead or underground. This concept is very clear. Now according to type of scheme of connection, so it may be ring, radial or interconnected grid system. Just have a look out towards the classification of distribution scheme. So first is radial system. In this radial system, this is the substation. Now we know what is a substation. Substation was that point at which 3 phase 3-wire system was arriving. So this is the substation, and there is now a transformer which is converting 11 kV to 440 volts. So this 440 volts is supplied to n number of consumers with the help of these distributors. Now the drawback, this is what is called as a radial system. Now in this radial system, the consumer which is near to transformer or near to substation will get a very good voltage. The consumer which is far away from this will have to suffer the low voltage problem, and this is the drawback of the system. Its advantage is it is a low cost system. Now let us have look towards this ring main system. So this ring is formed by using the multiple feeders. We can say this is a feeder, this is a feeder, and this is a feeder. Now we can see these are the various switches. Now say this is S1, S2, S3, S4, and all we can name in a proper way. Now see, this system is formed with the help of number of feeders Now any number of consumer can have the electrical supply from any of the substation or any of the feeder. Now let us say that this substation is under maintenance. This is having some problem. Now if it is having a problem, we will open this switch. We will also open this switch. So this will get isolated. Now from this we will close. We will close this switch. We will close this switch. This will be closed, this will be closed, this will be closed. Then the supply will come to this point, and from this point this isolator will be closed and these consumers will be feeded. Now we have seen if the substation is under maintenance, we can have the supply. So partly we will isolate this system by using these two isolators. Isolators are the switches which can make or open the electrical supply system. So we have opened this supply system with this help of this isolator, and we have tapped the supply from the other ends. So the consumer now, which was being fed previously from this substation, was now fed through this substation because of failure of this substation. Even if any of the feeder fails, then again that feeder can be isolated and remaining part of can be kept in the circuit. So this is having a better reliability of the supply. At the time of curriculum, we are going to study these systems in details. Just we have to look up, we should have a touch about these systems. So according to scheme, we have seen the two systems. It is having good reliability. Since there are many more feeders, our voltage level will be better, voltage regulation will be better. Now this is the third system, what is called as the interconnected grid system. Now you can say this is a grid feeder and this is connected to n number of the switches. Now any consumer can be fed through any of the feeder. This is the best advantage of this system. Now this can be, again the second alternative is, this is first incoming line and this is second incoming line. Both, by using any one of the line, we can charge the consumer, any consumer. So one line will be in redundancy or other feeders can be kept in the redundancy. Redundancy means alternate supply. We can, in case of failure of this transformer, what can be done? Other system can be kept in the circuit. So this is the best advantage. This system has highest reliability point. Consumers are fed, any of the feeder is under maintenance, then we can isolate that much part from the faulty feeder and we can keep the supply intact. So that is what is the advantage of this interconnected grid system. So these were the classification of distribution system according to the schemes.